algebraic expansion and factorization. Objective at end of session 202. Simplify algebraic exponential expressions and factor algebraic exponential expressions. So what's generally going on here is that we're going to do all the same laws we did before. So this you want to distribute, right? Let's multiply this a by both of them. Two binomials, all we do is distribute. We multiply the a by both, and we multiply the b by both. Same thing with all these. Don't forget when you have these, you can remember the formula or just multiply something by itself. Don't get lazy. Right? All we're gonna do, all is doing the same thing here. Is this that now they're gonna have ugly fractions. That's the only difference. So look at the first one here. So I can distribute. So I multiply this by this, this, and this. So really we're doing x to the negative 1/2 times x to the 3/2 first. Remember, all you do there is add the powers. So negative 1/2 plus 3/2 gets me 2/2, or x to the first. So that's that one times this one. And then we go plus, we're multiplying x to the negative 1/2 times 2 times x to the negative 1/2. Well, if you add those powers, you get 2 from 2 times 1. Well, let me write it. You have this times this. Right, so this gets me 2, and then if you add the powers, you get x to the 0. We'll talk about what that means in a second. And then the last one, we're multiplying x to the negative 1/2 times negative 3 x to the negative 1/2. So in this case, I get negative 3 x to the negative 1. If I want to simplify that some more, well, anything to the 0 power is 1, so this is just x plus 2 minus 3x to the negative 1, or if you want to make it nicer, x plus 2 minus 3 over x. Remember, in IB, it doesn't matter. Either way is fine. Next one. Expand and simplify. Well, it's the same idea. We're going to multiply this 2 by both of these things. So 2 to the x times 2 to the x plus 2 to the x times 1. Then we're going to multiply 3 by both of these things. So plus 3 times 2 to the x plus 3. Now, I have to be careful here. So 2 to the x and 2 to the x. Right, same base, you could add the powers. I know it looks funky, but it's the exact same rule as saying x squared times x squared. Oh, they're both x's, so x to the 4th. That's what's going on here. 2x times 2x, we're just going to add the powers. That's 2 to the 2x. Right, x plus x is 2x. Over here, that's just 1 times anything to itself. And then here, watch out. This is not 6x. Right, order of operations is 2 to the exponent first. You cannot combine these. This is just plus 3 times 2 to the x plus 3. You might think we're done. We're actually not done. I could add these two things here. Right, this is 2 to the x, 2 to the x. This is 3. This is essentially 1 times 2 to the x plus 3 times 2 to the x. Think about it like 1 rad 2 plus 3 rad 2. Right, they're both rad 2. So I can add them up and get 4 rad 2. Same thing here. 1, 2 to the x plus 3 to the x just means I have 4 of them. So this is going to be 2 to the 2x plus 4 2 to the x plus 3. I mean, it's kind of off-center there, but that's what's going on. 4 times 2 to the x is what I meant. And that's my answer. Okay, the next one. 7x plus 7 to the negative x squared. So, I'm not going to mess around. Just write it. And since we're squaring it, we're multiplying by itself. Like that. Then we're going to distribute 7x times 7x. Remember what we talked about. Same base, we just add the powers. So 7 to the 2x. And then the next one. Same thing here. Same base, add the powers. So that's plus 7 to the 0. Right? Because x plus negative x is 0. Move on. I get plus 7, add the powers to 0, plus, move on, I get 7, add the powers, negative 2x. So I get that. And then we can simplify this. Remember, the 0 comes from you add the powers. Negative x plus x is 0. Negative 2x comes from multiplying these two. You add the powers. Negative x plus negative x is negative 2x. Now, negative 0 power is 1. So remember, it doesn't go away. It's 1. So 7 2x. Plus 1 plus 1. I'm showing more work than you have to. I could add these up. I get 7 to the 2x plus 2 plus 7 to the negative 2x. And if you want, you can rewrite this one as 1 over 7 to the 2x, but this is fine. Alright, so again, a little funky, but the same rules apply. Then we get to this, and we want to factor. So the key with factoring, well, especially this first one, is this right here. We have to rewrite that. So remember what I talked about earlier, right? If you have x to the a times x to the b, that equals x to the a plus b. All the same rules apply. So if you see something that has a plus in it, you could separate it, right? It also works in opposite way. Oh, there's a plus. Let's separate to this times this. That's what we're going to do here. I'm going to separate that to 2 to the n times 2 to the third plus 2 to the n. Right, so this part became this part, and then the plus to the n on the side. So if you separate that out, because the plus sign just means multiplying an exponent, you get this. And now I could factor. These both have a 2 to the n. So you pull it out. Remember, when you factor, just divide. So if you divide this by 2 to the n, the 2 to the n's cancel out. You just get 2 to the third. Plus, you divide this by 2 to the n, the 2 to the n's cancel, you just get 1. That's my answer. 2 to the n plus 2 to the n plus 1. Actually, I might want me to simplify that. Let me see. So that'd be 2 to the n. This is 8 times 9. So something is 9 times 2 to the n. So I think either of these is okay, but that's probably a little better answer right there. So let's try the next one. So I'm going to do the exact same trick. I'm going to separate this. 2 to the n times 2 to the third plus 8. And I can't factor anything out here. Well, there's a couple things you could factor out. 2 to the third is 8. So I could write this as 8 times 2 to the n plus 8. And now they both have an 8. So factor out the 8. So it becomes, right, all you do is divide by it. This divided by 8 is just this guy. And 8 divided by 8 is just 1. So I get this. And those I cannot simplify for sure. Next one. So this is a little tricky. 2 to the 3n plus 2 to 2n. The general idea here is it's not like a plus sign where you can separate it. What we want to do here is factor out as much as possible. So this has 3n's, this has 2n's. So what's the most you can factor out? A 2n. So we want to pull out a 2 to the 2n from both sides, from both numbers. What does that leave you with? So remember, if you're ever not sure, factoring is dividing. So you just divide out what you factor out of. So if you want to think about, okay, I'm going to do this. Right? And what do you do when they're the same base? You subtract the powers. 3n minus 2n is 1n. So it's 2 to the 1n. And then over here, they're exactly the same. So just plus 1. And you get that. That's how you factor out that one. Okay, next one. I want to factor this out. So this is the difference of two squares. It's a squared minus b squared, which would get you a minus b, a plus b. Now what you're thinking, does it look like a difference of two squares? It is. I could rewrite both of these. This is the same thing as saying 2 to the 2x, right? Because 4 is 2 squared. And if you have an x around the outside, you get this. And then 9 is 3 squared. So we have a difference of two squares. So it's the square root of the first one. The square root of that's just 2 to the x. 2 goes away. Minus the square root of that one. Plus 2x plus 3. Right, difference of two squares. Right, so again, another way to think about this right here, if you have a hard time with that, is this is the same thing as saying 2 to the x squared. So that's one way you could write it. So 4 2x is this, which is that, which is the same thing as saying 2 to the x squared. And there's that one. The next one, 9x plus 4 to the 3x plus 4x. So the key here is we want to rewrite this as it's the same thing we just talked about. I can write that as 9, 3 to the 2x plus 4 to the 3x plus 4. And if it helps, you can rewrite this. This is the same thing as saying 3x squared plus 4 to the 3x. Should be a power plus 4. Like this. And then now, this is in what we call quadratic form. Anytime you have the second term squared, the first term squared, and this is half of the first term, you can just factor like normal. Like, how do you normally factor this? Some people call this a u sub. Like, you let this be u and u. So you have u squared plus 4u plus 4. And you factor this like normal. Where two things that multiply to get 4, but add to get 4. U plus 2, U plus 2. Alright, so U plus 2 has U plus 2 will get you this. And then don't forget, it's not really a u, it's actually 3x. This just helps you see it better. So you just go, okay, it's 3x plus 2. 3x plus 2. Also known as 3x squared. 3x plus 2 squared. So that's one way to do it. Another way to think about it is anytime you have something squared and then the middle term to the first power, you just factor like normal. So what are the two things that multiply to get 4? Add to get 4, so it's 2 and 2. And then put the term in front. See the way it works. Next, we want to simplify this. So what you could do here, you're not supposed to just reduce it. What you're supposed to do is combine it. So they both have an n power, so you combine it to 6 over 3 to the n, which then reduces to 2 to the n. So that's how you do that one. Next one, similar idea. Let's combine it first. So it'll be 4 over 6 to the n, because they both go to the n power. Then I can reduce it 2/3 to the n, like that. Okay, let's move on to the last example. It wants to simplify this. So for these, we're going to use some math rules to simplify it. So the key thing here is that these do not cancel out, these do not cancel out, and I guess something there would cancel out anyway, right? It's a general math rule, right? If I give you, what do we have there? 3 plus 6 over 3. This is not equal to 6. That does not, it's not a thing. No, bad. Right? How do you simplify it? You factor out what they have on, because there's an implied parentheses on top. You factor out what they have on top. What they have in common, which is a 3, and you get 1 plus 2 over 3. These reduce and you get 3. Right? That's what we want. So we want to be able to factor out the top and then cancel out, because we can't just cancel out willy-nilly right there, because there's implied parentheses. Same rule here. I can't just cancel out 3n's, there's implied parentheses. So I factor out a 3n. Now remember, you can factor out, factoring out is just dividing, so you can factor out a 3n. And all we do is divide both of these by 3n. 3n divided by 3n is just 1. 6n divided by 3n, right? We just did that. Since they're both of the same power, you just really just cancel these out. It's the same thing as saying 6 over 3n, which is 2n. Since they're the same power, just divide. This is all over 3n. These cancel out now, and you just get 1 plus 2n. So there's that one. Same idea here. Now this one's a little different. 2 to the n plus 2. So remember, the trick with this is rewrite it. This is saying 2m times 2. Right? It's not like here where there's not a plus sign. There's different powers, different bases. So I get this. So if I'm going to rewrite it, I get 2 to the m times 2 minus 2 to the m all over 2 to the m. And now on top I can factor out the 2 to the m. So you pull it out. You're left with 2 minus 1 over 2 to the m. And then 2 to the m's cancel. You just get 2 minus 1, which is just 1. Like that. And the last one here. So I'm going to do the exact same thing on top. We'll make this 2 to the m times 3 plus 2 to the m over 9. Now, that doesn't cancel out, but I could factor out the 2 to the m's. So I could pull these out, and you get 2 to the m. What's left over? 3 plus 1 over 9. This is sitting as 4. So I get 2 to the m. I guess you could write it like this, 4/9. But that's about as much as you could do. Nothing else to do with that. That's the lesson.